2016 BLG 1195LB is the first planet we're going to be talking about today. OGLE 2016 BLG 1195LB is an icy exoplanet that can be found a whopping 13,000 light years away from our solar system. Its temperature ranges from negative 220 degrees Celsius to negative 186 degrees Celsius. For the Fahrenheit people out there, from negative 364 Fahrenheit to negative 302 Fahrenheit, which is why it's sometimes called the ice ball planet. A light year, for the people who don't know what a light year is a measure of relative distance somewhere that's 1 year away if you're traveling at the speed of light. The speed is equal to almost 300,000 kilometers per second, or over 1 billion kilometers per hour. So you have to travel a long way at a high speed to see this huge ball of ice. So far, the fastest speed we've ever reached in space occurred with the New Horizons, a space probe launched in 2006 to conduct a flyby study of Pluto, its moons, and the Kuiper Belt. New Horizons speed along at over 58,000 kilometers per hour, a far cry from the speed of light. So you can see that we don't have the technology yet to visit our nearest neighboring system only a few light years away. That's why we use long-range technology to discover distant exoplanets, as well as to determine their mass and the makeup of their atmosphere. The ice ball planet was found using a microlensing, a process used to discover planets when they pass in front of our stars, and we see the stars dim briefly. All the ice on the ice ball planet is thought to be freshwater. Although this is good, it's unlikely that we will be able to use this water in the foreseeable future. It would take 13,000 years to get to the exoplanet traveling at the speed of light. Perhaps an advanced alien race uses this faraway planet as a source of fresh water. Next planet we're going to be talking about is the Kelt 9b. The Kelt 9b is the hottest exoplanet ever found, and it's disappearing. At 650 light years away from us, Kelt 9b is tightly locked with its star, meaning that one side is constantly facing the star and one side is not. The gas giant is approximately 3 times the size of Jupiter and burns at a temperature of 4,315 degrees Celsius. This is hotter than most stars and almost as hot as the surface of our sun, which burns at 5,505 degrees Celsius. A few million years from now, Kelt 9b will have burned all of its gases and will disappear, leaving nothing but its lonely star. The next planet we're going to be talking about is GJ1214b. It's also known as the steamy water world. GJ1214b is a huge water world, 3 times the size of Earth, that can be found 42 light years away from our solar system. Earth's water is equal to 0.05% of its mass, while GJ1214b's water contributes 10% of its mass. GJ1214b is thought to have oceans that might reach the depth of as much as 1,600 kilometers. That's also as 1,000 miles. In contrast, the deepest part of our own oceans in the Mariana Trench is 11 kilometers, 7 miles deep. We have only explored about 5% of our ocean. We have found countless astonishing creatures that we never expected to exist. Imagine what horrors lies within the deep waters of GJ1214b. The next planet we're going to be talking about is PSR J17191438b, also known as the Diamond Planet. a large carbon-based planet with a five times that of Earth. PSR J179119843 can be found about 4,000 light years away from our solar system. Due to the immense pressure caused by the planet's gravitational pull, the carbons has been condensed, forming a gigantic diamond. The exoplanet orbits a millisecond closer named PSR J1791143. Astronomers believe that the pulsar was a massive star that became a stellar in a supernova that rarely a second pulsar, supposedly formed by radium material from a companion star. In this case, the companion star was probably a white dwarf, which is what our sun will become when it dies. A white dwarf is a remnant that has no more nuclear fuel. Here's the millisecond pulsar probably ate the materials from its companion white dwarf with only 0.1% of its mass left. The white dwarf then formed an exotic crystalline composed to the pulsar, the diamond planet. The next planet we're going to be talking about is the Kuiper 16b, also known as the real-life Tatooine. Kuiper 16b is essentially the real-life equivalent of Star Wars planets, Tatooine. This is because Kuiper 16b is one of the only exoplanets ever found that orbits a binary star system. Kuiper 16b has a mass about 105 Earths, and it's 8.5 times the radius of our world. The exoplanet has an atmosphere comprised of hydrogen, methane, and small amounts of helium. Approximately 200 light years away from our solar system, Kuiper 16b completes an orbit around its two stars in 627 of our Earth years. Although it may look like Tatooine, Kuiper 16b cannot support life, so don't expect to find any droids there. The next planet we're going to be talking about is the Kuiper 10b, also known as the Scorcher World. Kuiper 10b is the smallest exoplanet discovered to date, and we believe that the surface is covered by ocean of lava about 560 light years away from Earth. Kuiper 10b was the first rocky planet found outside of our solar system, marking mankind's first step toward a future of space exploration. The surface reaches a temperature as high as 1,400 degrees Celsius. As a result, rock on the surface melts, pooling into large areas and causing huge lava oceans scattered across the exoplanet's small surface. Due to its high density, it is believed that Kuiper 10b contains a high amount of iron, which would cause that lava to appear a brighter shade of red. The next planet we're going to be talking about is the TREC-2b, the dark planet. TREC-2b is the darkest exoplanet ever found, reflecting less than 1% of the sunlight that hits it. That makes it darker than coal or black porcelain paint. That actually a miracle that we found that the planet because the light was so scarce. That raises an important question. How many exoplanets have we missed due to the lack of light? TREC-2b is about 750 light years away from our solar system. Its atmosphere contains vaporizing sodium, potassium, and titanium oxide, all of which absorb light. However, it is a small mystery as to why the planet is so dark, a mystery that may never be solved. Perhaps an alien race inhabits this strange planet and we just don't know about it. The next planet we're going to be talking about, it's HD 189733b. The planet is also known as the planet that rains glass. Perhaps one of the most interesting exoplanets on the list. HD 18977733b, which is 63 light years away, rains glass. Sideways? Yes, you heard that right. The hellish planet winds can reach speeds of up to 8,700 kilometers per hour, causing any strange precipitation to fall sideways. A silica concentrated atmosphere causes the planet's cloud to rain molten glass. which hardens as it falls. HD 189733B's wind pushes the glass at such speeds that shards fly through the air horizontally, slicing up everything in their path. Imagine getting stuck in that storm. The next planet we're going to be talking about is 55 Cancri E, the planet with the weird water. 55 Cancri E is tidally locked with its sun and has water on its surface that is both liquid and gas. The exoplanet orbits 25 times closer to its star than Mercury does to our sun, and completes its orbit in only 18 hours. That's extremely fast. Since 55 Cancri E tightly locks with its star, one side constantly faces the sun and the other does not. As a result, the water facing the star is in a supercritical state, causing it to be both a liquid and gas at the same time. 55 Cancri E has the most of around 7.8 times that of Earth, and it's roughly twice our planet's size. The next planet we're going to be talking about, the last planet we're going to be talking about on this list, is the COROT 7b, the planet that snows rocks. COROT 7b is a bizarre exoplanet because it snows rocks. Like many other exoplanets, it's tidally locked with the star. The side facing the sun reaches a temperature as high as 2,200 degrees Celsius, while the other side drops as low as negative 210 degrees Celsius. Lava on the star's side is heated so much that it evaporates, much like water does on our planet. That creates a large stone clouds that later condense on the relative cooler side of the planet, which it rains large rocks. If we could survive the extreme temperature of this planet, it would be sight to see. On the hotter side, it rains magma. On the cooler side, the magma hardens before hitting the ground, much like snow does on Earth. This creates rock snow that will kill you if you happen to be in the presence. I hope you learned something today, and I hope you enjoyed the video. And this is it for the video.
Peter Pan, that's what they call me. I promise that you never be lonely. Peter